Sadly, my computer is too old to record.
To confirm to the technology standards. Yeah, thank you so much, everyone who's here, especially Tommaso and Sebastian, obviously, for inviting me. As you said, Tommaso, this is like a continuation of a conversation we've already started or already had. I'm very happy to be here and to discuss this a bit. As you'll see, I know we already talked about some suggestions. I didn't manage to like entirely realize them, but maybe we'll talk about this later. Yeah, and as Sebastian said, I I have to say now, because I was a research fellow at the Weizenbaum-Institut in Berlin till yesterday. And I arrived back in Vienna sort of yesterday, and unfortunately it's done. It was a very good time, so I can only suggest anyone who wants to spend time at the Weizenbaum-Institut to actually do it. Yeah, so I was thinking for the hour, which is quite a long time outside of teaching. I don't think I've ever presented anything this long, but so I was thinking that maybe it would be good to present like the general logic and structure of my dissertational work, and then go into the one chapter that I've already discussed with Tommaso and Sebastian a bit. And then maybe we can talk about preliminary results, which I have for another chapter, which is based on interviews, so qualitative data, which is quite the shift. Yeah. So I guess in very general terms, I think I would say, let me just see if I have this right. Yeah. My dissertation generally concerns sort of like how automation has changed work and employment in the automotive industry, specifically the Central European, even though the first chapter will be more expensive. And roughly over the past decade, right? Or between the two big economic crises of the early 21st century, which is of course the global financial crisis and COVID. Right. I mean, ultimately, I'll be interested to hear all of your thoughts. Yeah, let's like any suggestion or critical feedback that you would have, I'm interested in. Let's put it like this. Okay. Did you see it? Did the slide move or?
Yes,
it does. It does.
Perfect. Okay. So what is the background to all of this? I think I hardly need to stress this in this group or here. But essentially, obviously, the last years up to a decade have once again seen a resurgence of questions on automation and the future of work. I find here the characterization of Benanaf as an automation discourse to actually be most useful. And this discourse contains two essential features, I would say. These are for me. Benanaf has similar ones, but they're not from him. The first one is that the recent technologies are obviously the most important driving force in changes in work and employment. And secondly, that progressing automation is eradicating employment like never before, right? Obviously, both points have been critiqued extensively already, also by Tommaso and Sebastian, among others. But okay, what interests me most about this is essentially to ask, maybe somewhat provocatively, why hasn't automation already gotten rid of all work? You know? And now we're in the general structure of the dissertation, obviously. And one of the ways to look at this, or to sort of like tease this, is perhaps this figure, which shows industrial employment and robot densities of the 30 largest automotive producers in the world for the year 2019. Well, I mean, obviously, this is a very contentious figure, right? Like we can talk about this very extensively, what it means or what it doesn't mean. But I just wanted to show essentially two things. First of all, that manufacturing employment persists. It's not even in developed economies or like the most developed economies. So it's not like a thing of the past where we say, only the interesting things are happening in the service sector and manufacturing is going the way of agriculture. I think this cannot be maintained. So that's the first point I want to make. And the second one is that at least for a small group in this sample, it is quite striking that there's a very high rate of industrial employment compared to their degree of automation. So there's at least a couple of cases here, starting with Austria, industrial sectors which are very highly automated, but also still have a lot of employment, right? Which is obviously counterintuitive if we take the basic narrative at its level. Yeah, and obviously, I mean, this is 2019. Obviously, things have changed quite a bit since the 50s, and there are tendencies which are correct and which must be reflected. But I think these 2 points can be made with this figure, so to speak. Coming back to what I'm interested in, so I mean, again, my question is like, after centuries of automation, why is work not done, right? Why is it not ousted from production? And why does the end of work that everyone keeps talking about never come, right? And also, why doesn't it get better? Why is the promise of, you know, high-skilled jobs, which are constantly improving, always disappointed? I mean, the name of the game today is obviously the example of gig work, right? I think, I mean, obviously, this is too big a question to answer in a dissertation, but I also think that it can be narrowed down in the sense that it is particularly interesting for the manufacturing sectors of the global north, because they would have like most of the requirements for maximum automation, right? So the technological capacity, the high wages, and established history of deindustrialization, essentially, right? So in these cases, it's especially confusing. But again, this is also too big to ask in a dissertation. So the more specific thing I want to ask is what explains the persistence of manufacturing employment despite increasing automation in the Central and Eastern European automotive industry between 2010 and 2019. So this is the most specific empirical frame. I'm still a bit torn of putting this a bit differently, and maybe here also I would be very interested in your input, because obviously it might be a bit better to just put the whole question as how has automation changed or affected work and employment in the Central European automotive industry. But yeah, maybe if later on you have some thoughts on this, which is the more preferable dissertational question, let me know. Right, so this is the general idea, the general question. Obviously, there's some hypotheses I have thought, or we can think intuitively about to answer this. The first one is essentially perhaps all of this has something to do with the development of labor productivity, right? So if more automated countries are more productive, maybe there's no need to move production away. So essentially like a reshoring argument of sorts. Or alternatively, if productivity has been stagnating, as some claim, as we'll later see, then perhaps this can explain employment persistence. So if productivity is not increasing, obviously you still need people to do the work to get the output. This is the first hypothesis, which my paper, which I'll present later, addresses more directly. But there's obviously other things to consider, and the second and third hypotheses, which you see on the slide, which I hope you see on the slide, are more concerned with the structure of occupations and firm differences along the commodity chain. So I will not go into this now, because I've also not started working on this chapter, unfortunately, but about this we can also speak later a bit. And the fourth hypothesis is simply that there's very clear limits and boundaries, non-technological limits and boundaries to automation, or how much work can be displaced through automation, based on the politics of production in factories and sectors and so on and so forth, which is the hypothesis that my third chapter then engages. I think, I mean, I have some general literature connections here. They're mostly like in terms of critiques, formulated in terms of critiques, that have no specific references except for Butterloh and Nuss. I think I'll just skip this. Yeah, so far on the general dissertational project. Should we talk about this already, or should I continue presenting the first chapter and then we do both in one swing?
Everything is going fine. Do whatever you want. That's fine. Okay. I think
okay.
You can go either way. I think they're both interesting as you feel more at ease.
Okay. Then I'll just be plowing on. Maybe get it done. Yeah. Okay. So as I said, so the first chapter kind of addresses this first hypothesis or this first question of what has been going on with productivity and employment and automation. Essentially, what I did not mention before is that in the automation discourse, there's quite a specific and important sub-debate, which is on the productivity paradox. Also an old debate. It has like antecedents in the 80s and 90s when the computer first came up. But essentially, there's new proponents now which are discussing this, and it sort of like posits that productivity growth has been stagnating in OECD economies, right? Despite technological advances. So even though it should have been accelerating, it was actually decreasing. The first paper sort of connects to this, my first paper, in that I think that mostly missing from these debates are the gaps, as I see them, are the concrete empirical variations of what people are actually talking about. This concerns specific sectoral evidence. So for me, looking at the automotive industry, and also specific technologies, like me looking at industrial robots. This has certain drawbacks, which we'll also get back to, like the specificity, but I feel like it's a very, because the productivity stagnation debate is very abstract. It's very grand terms. Yeah, so this specificity I think is needed. And also to consider how things may be more related in a greater complexity, like variables which are interrelated, which my contribution here is to consider competitive dynamics in productivity and automation, which so far I think has not been done. I mean, it's not a great achievement, but it hasn't been done to have all variables together. Yeah, so the paper essentially what it wants to do is to see how labor productivity has been affected and employment has been affected by automation and concentration or competition in the automotive and general manufacturing sectors of 26 OECD countries, in order to get a better idea and to get some grasp on the hypothesis of the persistence of manufacturing employment, as I've said earlier in the dissertation. Okay, maybe in all brevity, what is the context? What has been going on with labor productivity? Essentially, several people have now claimed that since the early 2000s, labor productivity growth has been declining in all developed economies and all sectors. They always make the specific point that manufacturing is contained in this, whatever manufacturing means. This is a very highly aggregated category, obviously. And among the explanations that are most prominently suggested, and I identify this mostly with the work of Goldin et al., are the ones you see on the slide. Among them, I focus on the ones, first of all, that I believe are most interesting. Secondly, which also have their own debates. So, and I think which connect the nicest throughout the entire problem. And the first one is the stagnating effects of increasing concentration or monopolisation, as has been postulated as a new age of stagnation and monopoly, and the lacking productivity effects of new technologies. So these are the two explanations of the productivity growth slowdown hypothesis that I somehow engage. But of course, this is not a void. This connects to work that has been done before, which are essentially these literatures. And those are also the literatures I most directly contribute to. The first one being the effects of monopolization or competition on productivity. They're very difficult to summarize, especially the first one, because the theoretical argument is obviously overdetermined, right? Depending on economic school of thought, you would have a different assumption of how concentrated markets or low competition or high monopolization affect productivity. So it's very hard to, and there's a lot of them simply because it's a very fundamental question of economics or economic analysis. Yeah, so the contributions I collected, so to speak, are theoretically overdetermined and also empirically ambiguous. So it's not clear or everybody finds different results, so to speak. And that's the first literature. And the second one is a more straightforward literature, and it's also more recent. and decidedly from economists again. It's the effects that robot use has had on productivity and employment. In terms of productivity, it's fairly clear because it's also intuitive. They find, most of these contributions find that robots have been productivity increasing, which is understandable. But regarding the employment effects, results are very ambiguous. Okay, so again, we have here like a split between, we don't really know what's going on, which lends credence to the ambition of being specific in the analysis. Okay, so these are these two. Exactly, and my contribution again is like to connect this, to make it empirically specific, and consider what is going on precisely. How do I operationalize all this? The variables essentially that I am interested in are robot density, as I said, which I take as an approximation of automation, which is a very bad, intellectually it's very insufficient, but we'll talk about this. And essentially it describes the number of robots per 10,000 workers. And I take this from the International Federation of Robotics database, and the robot density is actually also from the yearly reports, because I didn't want to calculate them myself. Then the second variable is sectoral concentration, which I take to approximate competitive conditions or rather outcomes. I mean, this can also highly be debated quite a bit, especially the relation between firm size and so sectoral concentration and the competitive pressures, because as Anwar Shaikh, for example, maintains that independent of the size of a firm, they can be under immense competitive pressure, which of course makes sense. Like we can imagine BMW or Audi, you know, still experiencing pressure for market shares, but at the same time, it's a strange conflation, I think, because it's not the same as two bakers in some street in London, you know, not being able to determine the prices. So what's going on between these oligopolies is not the same type of competitive pressure as, yeah. So I think Shaikh is here making a simplification. And the third variable is obviously labor productivity. I did not go for total or multi-factor productivity because I think they're too, for me, they're too constructed. They're, I mean, economists love to sort of like trump each other in how far away from the reality can we get with our data. They come up with all these indices and indicators and stuff. But yeah, I don't find total or multi-factor productivity very convincing. And labor productivity is a very intuitive indicator. It simply it must say something because it's very concrete. Yeah, the control for the estimation later is capital intensity, obviously, which is capital stock by hours worked, which I've taken mostly from the WIOD database and CompNet. Yeah, so I mean, I'm very aware that these operationalizations are very contingent and they're not optimal. And really, if we're intellectually rigorous, then they do not represent what I want them to represent, right? This was also a conversation in Modena with Margherita Russo. And this is true, I see this, but at the same time, if we do quantitative work and if we want to do it, it must be a curtailment of reality, as it were, right? So I think it's logically unavoidable to not have the thing that you want to represent actually be represented in the data. This is maybe a bit of an epistemological point, but yeah, so I'm aware of this. I agree with it. I just don't see how we can do other work. But yeah, maybe we'll talk about this later a bit, what this means. Okay, who are the countries that I'm talking about? What is my sample? Essentially, I did the following thing. I selected the most relevant car producers in the world in terms of per capita production, and then just chose the top 30. Right? That was the first thing. This already means a lot of bias again, because first of all, it's a bias towards assembly rather than parts production, because the countries are measured by how many cars per capita they sort of like produce or put out, and you can only put out a car if you actually have assembly, right? So this is the first bias, and secondly, this ranking goes after the national importance of automotive industries, because we calculate it by capita, right? If we took it in an absolute sense, this would be an entirely different analysis, right? Because then we'd be the highest volumes, we'd be talking about China and so on and so forth. And in this list, Slovakia is actually the number one, right? Because per capita, they do produce the most cars, final cars. And I think this is fine. It's good to be aware of this bias, but I think it's fine because we're interested here in the structural movements within the industry rather than the global structure of the automotive industry, right? Because then again, we would be largely talking about China, I think. So those are the 30 countries. I then added to this list the largest European economies to sort of get the full picture for the comparison. And then I also added a special area focus because obviously that's also a or the focus of my dissertation on Central and Eastern Europe, which has obviously a specific role in the automotive supply chain, especially the European one. Yeah, so then I maximize the availability, see for which countries I have data or the most amount of data. And in the end, this left me with the final panel of 26 countries. Which you see on the slide. The estimations follow, there's several panels for the estimations. There's 3 different panels, but I'll describe them as they come along. And mostly it gets more conservative. So the 26 country panel is like the widest. It also took a long time to assemble, and it's pieced together. It's a Frankenstein data set. And the others are pre-made standardized data, but contain fewer countries and fewer years. Okay, let's start looking at this thing. The first figure which you see now is essentially the averages of the relative changes of labor productivity in the countries of the sample, right? Separated by sector. In relation to the 2000 values. So in the year 2000, the values are indexed at 100. Right? Right. I mean, what do we see here? Not much, which I think is quite interesting, because from this perspective, labor productivity has sort of like been quite boringly increasing for the aggregate sectors. And there doesn't seem to be much going on. I mean, okay, we have a dip actually 2012 for the automotive industry for some reason. 2009 wasn't even a big thing. It just went straight. So it's a fairly harmonious kind of development. I mean, for the automotive industry, not so much maybe, but still. Yeah, so this is strange. But first, before we look at individual countries, it's also interesting to look at a different panel now, because the panel that this figure is based on is nominal value added in national currencies. And if we translate this to real value added, so corrected for inflation, corrected for purchasing power, and transferred to US dollars, we get the following figure. Okay, this is a little more exciting, because now we actually see the dip with the financial crisis, which makes sense. And then we also see that after the financial crisis, so 2009, 2010, yeah, something's been a little different than between 2000 and up to the financial crisis, right? So maybe there is something going on with the productivity paradox, but it's also not super entirely clear just from looking at it. And also, as I said, like in these aggregate sort of analysis, we don't really know how individual countries are doing or have been doing, which is why I have compiled this. I'm very sorry, this is like a wall of numbers. So these are essentially compound annual growth rates for most of the countries in the sample, and according to 3 different panels of data. Essentially, compound annual growth rates say how much does a value have to grow each year in order to reach the final value. So again, we're like of a time series. So again, we're sort of like leveling the actual movements, but it's a clearer picture than just looking at the graph. And essentially here, I just want to point to the red figures, so the ones I've colored in red. And those are the numbers where productivity growth actually does go below 2%, which I now set as a mark for stagnation, so to speak. And it's not a lot of cases, as you can see. Like looking at the entire period, naturally also is there's not a lot of cases that can actually be sort of like labeled as productivity stagnant. The third, the P3, the panel 3, is the one with the real value added. That's the second columns from the right. This is sort of like the most adjusted one. But interestingly, with the nominal panels, we see that it's mostly the automotive industries of the US, Portugal, Japan, and Canada, which are sort of like, according to this definition, which have seen serious or stagnation at all. But again, like compound annual growth rates are also a choice. They're a choice of metric to be looked at, which is why there's another one. Exactly, where we can see year-to-year changes theoretically a little more clearly. And these are 5-year centered moving averages. Again, I'm sorry about the wall of numbers, but this is also the measure that Golden et al. Use. So one of the, I think, prime proponents of the productivity growth stagnation. And essentially, what we see here is that every number which is colored red is smaller in the second period compared to the first. So essentially, those are the data separated into 2 periods. And what I did here is I just took the change of subtracting them. And the point is now we see, yes, like in the second period, which is 2006 to 2018, actually in all countries and all sectors, on average, growth rates have been smaller than in the first period. So this is in this there's quite a nice sort of confirmation. But I mean, I've been talking about these different measures and what they mean or not. And when we look at the next one, this is essentially the year to year, because the table above is averaged again, and these are the year-to-year changes. So this is what's problematic both here and both in the diagnosis of Golden et al. Is that if we look at how the automotive sectors have changed from year to year, it's very volatile, right? So every time we would take an average and we would sort of like pretend that this was one linear development, we lose a lot of meaning, because, for example, I mean, in the Canadian automotive sector, it grew from 2002 to 2003 by 6%. Then the next year 11%, and then two years later it declined for 2 years, and then it sort of went back up again. So it's like and that's the same for all sectors essentially. There's great volatility, which these averages simply hide, right? Even though we can reproduce the claims of the productivity paradox. But I would say it's not unconditionally true, and it depends on very volatile movement. Okay, moving to the sort of approximation of automation, robot density. What I've plotted here are average robot densities. So again, the absolute number of robots per 10,000 workers for both the automotive and manufacturing sectors. For the countries of the sample, obviously, between 2010 and 2019. And we can see they increased quite steadily. Right? I think the most important takeaway that I want to stress is how heavily skewed the distributions of robots are. This is obviously something which will not be surprising to Jarpisa, but it's something that is usually surprising to most people, and especially also economists like working on robot data. I mean, some of them do look at the subsectors where they're actually implemented and applied, but many just treat manufacturing as a monolith. But obviously, if you then open it up, then there's a great difference of use, and the automotive industry accounts for most of them. And within the automotive industry, the top 5 countries again account for most of the robot use. So industrial automation through robots is a very unequal affair, I would claim. Exactly. Okay. I mean, still it has been increasing. Also the manufacturing sector. We can't see it in this slide nicely, but it has doubled in between 2010 and 2019, the robot density, essentially, the average robot density. Concentration, again, almost the same. There's a very different level for the automotive sector compared to manufacturing. And obviously it's much higher. So what we see here is a C10 measure. It essentially means the percentage of revenue that is being taken by the largest 10 firms in a sector. So on average in the automotive industry, this is like 80% of the revenue. This is probably a conservative estimate. And in manufacturing, it's still high, but much lower than in the automotive sector. Right? And these are fairly steady developments. So if we talk about I mean, I guess we have to look at the entire economy, but talking about a new age of monopoly always strikes me a bit weird, because in manufacturing, it's a continuation of an old age of monopoly. Like it's not, especially the automotive industry, right? Like there's nothing, of course, Google, Facebook, Apple and stuff, they're new and specific. But if we want to say something about the wider economy, we also have to consider that this has been the picture for a long time. Okay, to conclude sort of like the descriptive analysis of all this, what do I want to say? So, I mean, again, I want to say regarding the labor productivity paradox is whether the paradox is true or not. I think it represents on the contingent point of view, which I have called a parallax. So while we can replicate it, if we choose a different measure or a slightly adapted panel, the severity does disappear. So I would doubt, or I would draw into question a bit the strength with which people usually claim this paradox. And in order to say something substantial really about any of these variables, one needs to be specific in which country, which sector, which time, what has happened and for what reason. Robot density, almost the same. I said it has been increasing significantly, but with a heavily skewed distribution. And there's also no revolutionary breakdowns apparent. It's a very steady development. And it's also something that people have, or engineers in the Austrian automotive industry have been telling me in my interviews for the other chapter. They've been saying essentially the problem of robots was solved in the 80s or 90s. Like that was when it was last a big technological question. I mean, of course, there's developments and stuff. But for them, it's very clear that this is not something which is happening now and which is really, really sort of like explosively revolutionary. They've been doing it for a long time. Yeah, and the same with concentration. So of course, I mean, the question now becomes how can we sort of be more rigorous, if we want, about these interrelations and sort of maybe find a general trend, like how these things have interrelated. The model I have used is a fixed effects model. It's a fairly simple affair. So a country and time fixed effects model to account for heterogeneity of group and time. So essentially get rid of the different intercepts. And I got to the fixed effect estimator by subtracting the group average, obviously, from each observation to remove these unobserved effects to get at this final reduced form, which you see below. And obviously, labor productivity is the dependent variable, and robot density and concentration measures and capital intensity are the independent variables. I also switched this up, obviously, in terms of checking robustness and stuff. And this is the most worthwhile specification. So, yeah. And the result of this model, using the panel with the nominal value added output, gives us this result. Again, sorry for the wall of numbers. But the interesting result here is that essentially everything is significant, right? So, I mean, this is already good and this is already interesting because it means that concentration is a relevant factor and robot density is a relevant factor in explaining labor productivity. However, they're diametrically opposed, right? So in the automotive industry, higher concentration increases labor productivity. In manufacturing, it reduces it. And in the automotive industry, higher robot density decreases labor productivity, and in manufacturing, the opposite. And this result essentially is the prime point of the paper, is to explain this, because really it does not make sense to have a higher robot density reduce labor productivity in the automotive sector. So it has something to do with what's going on there. But also what we see here is the nominal panel, and actually to sort of like be more serious and check it. So I'm just lost where I am. Okay. Check it more seriously, we can also run this with the different panel, which is the most highly conservative adapted panel of real value added, corrected for purchasing power and converted to US dollars. And we see that we do lose significance a bit. For example, concentration in the manufacturing sector doesn't matter at all anymore. It still stays positive and significant for the automotive sector, although it jumps to indicators, which I haven't figured out why. And robot density, very classically in line with all the other results of previous studies, affects labor productivity positively in manufacturing. And in the automotive industry, it's still the case that it affects it negatively. So still in this most conservative panel, and with reduced significance, we have to admit it, labor productivity is reduced. But this is, so to speak, still a very strange result, which I think cannot be simply relegated to there has been made a mistake. I mean, I checked the data and the estimation plenty of times. I am very sure that there is nothing wrong with these aspects, so there must be a structural explanation, right? Okay, this I said essentially. Let me have a look. This I already talked about. Okay, I mean, it's also good to remember that for both of these models, there's very low adjusted R-squared values, which means that not a lot of the variation of the data is accounted for, and thus it's very bad for prediction, the model, which I'm not bothered by, I have to admit, because I still think that the beta coefficients say something meaningful, which can and must be sort of interpreted. And obviously, it's not surprising. First of all, because of the fixed effects model and the increased penalty, the R-squared penalty you get from using dummies and all, but also because labor productivity is a very complex variable. Like, it would be very strange if one specific technology or robot density would explain like 99% of what's going on. This obviously wouldn't make sense. Okay, so as I said earlier, the question sort of like becomes, why has robot density reduced labor productivity in the automotive sector? And this is essentially the last part of what this will be about. And I think it's quite clear that no firm and no aggregated sector would intentionally decrease their labor productivity, right? This seems not feasible, so there must be something structural going on. And we know that labor productivity and robot density have two moving parts each. So in the case of labor productivity, it's value added, so the output, what is produced, and the hours worked. And in robot density, we have employment, or the hours worked, and the number of robots. Right? So we can simply see how have these individual parts been affected in order to better understand what's been going on with labor productivity. And this is what we see here. But this is only for, I have to look. Yes, this is only the panel for real value added, because running these separated regressions again, so one, the hours worked is dependent and one value added is dependent, with the nominal panel gives a very interesting result in that I think in the automotive industry, robot density only increases hours worked, and in the manufacturing sector, it only increases value added, which would have been a bit easier to interpret. But running it with this conservative panel again gives us this. where essentially both in manufacturing and in the automotive industry, robot density has been affecting both variables positively. Okay, so both hours worked as well as output have increased based on higher robot densities, which then only leaves one explanation for the overall decline of labor productivity, which is that the increase of hours worked has been larger than the increase of value added in the automotive industry. So you see, I'm coming from puzzle to puzzle to puzzle, and it's actually quite. I'm still working on it. It's still very difficult to sort of like pinpoint, but I've tried to follow Tommaso's advice, and I tried to separate the countries again. So return to the descriptives and try to solve it through a typology of sorts, and this is what it is. I mean, this is not. Yeah, okay. So the first category of countries are essentially those for which it is true that productivity has been decreasing, but robot density has been increasing, except for Mexico and Japan. I still put them in this category. And where the decrease in productivity is driven by a higher growth rate of employment than output, right? So essentially, it's these countries, Canada, Mexico, Japan, Hungary, Poland, Turkey, which should be driving the results of the model, theoretically. Because if we look at category 2, all of the countries essentially had positive productivity growth. I mean, they're very different. For example, the US had only 0.7%, but they all had positive productivity growth alongside increasing robot density, except for France. France and Italy, I think. No, Italy had negative robot density growth. France had positive growth. Yeah, okay, maybe we can speak about France more specifically, which might be interesting for Pisa. But yeah, so the second category, employment has decreased at a lower degree than output, right? So essentially, the answer to this must lie in the difference between these two groups of countries. It's for me so far. I mean, this is also again a question I would like to put to you, because I was hoping for a very straightforward core periphery dynamic in explaining this. But I mean, Japan would hardly be a periphery country, right? Hungary, Poland, yeah, semi-periphery, Turkey as well, Canada, specific troubles, I don't know, but we also in the second category, we also have Slovenia and Slovakia, Romania, Czech Republic, so yeah, so maybe the knowledgeable eyes of Jacques Pisa see more in this difference than mine. Exactly. I mean, obviously, I have some thoughts, I have some ideas, and again, what we want to explain are the reasons for why hours worked have increased more than value added in this first set of countries. And what I was thinking of is that maybe it's a question of lower prices of products, lower costs of production, and that they sort of like tie into lower value added, which would explain why it hasn't increased that much, even though work has increased and therefore more has been produced, most likely. Or perhaps it's something to do with that they're only producing intermediary products and sending it elsewhere where the value added is then realized. But then it's strange for Austria, because Austria only does this mostly, and it's still in the second category. Then again, maybe there is some core periphery dynamic I'm not really seeing. And another explanation I could think of was that maybe increasing the hours worked does not necessarily mean higher output. It could be, I don't know what, but maybe there's something else going on. For example, I don't know. I don't know. Maybe there's no direct relation between more production and more hours worked. Engineers, for example, I don't know. Those are essentially the sessions, and I'd be happy to discuss them with you. Okay, I'll really briefly, I'll again go through the main points. Okay, so I've argued that labor productivity slowdowns, the productivity paradox, suffers from a parallax effect. So it's not, it depends on which metric is chosen, whether it can be identified. Robot density, steady increase, but no revolutionary breaks, and very highly skewed, concentration the same, and levels very different between automotive industry and manufacturing. The inferential analysis, I think, has shown that sectoral concentration and robot density are interesting and relevant explanatory factors for labor productivity, but they're not the entire story. And in sort of like explaining this difference between manufacturing and the automotive industry, we have to consider the difference of value-added developments and hours work development. Okay. But in explaining the specific problematic situation of the category 1 countries, as you see, I'm still a little bit at a loss, which probably also has to do with the limitations of this study a bit, because it's only one sector. Except for the revenue data, I have no firm data. This also ties in a bit to what you said, your suggestions on how to drive this paper forward, Tommaso. So I have no firm data. I have no additional automation data. I mean, using only robots, it's such a constraint metric for understanding industrial automation. I mean, Martin Kaczynski has also obviously written quite a bit about this recently. And there's also something we discussed. It's the limit of this very standard economic approach or economistic approach. If you always aggregate things and only deal in the aggregations of variables, naturally you run into strange, strange findings. Or I mean, people mostly publish the ones which are not strange, but it's a very clear limit of the standard economic approach, I think, which is why the following 2 chapters of the dissertation of me will be precisely about critiquing this a bit, or going into more specific facets, and also changing methodologies to actually understand the specifics behind the aggregation. This also connects to what I think is missing from this entire thing, and it also connects to your suggestions, Tommaso, because I was not able to integrate them fully, because I want them to be part of future research or the next chapter, which again is the size of firms and the inter-firm relationships and how they determine these results, like where the OEMs, where the tier 1s, how are they in the supply chain connected, right? So the core periphery along the supply chain, regional level differences, it's also a big question, like how much is Slovakia really producing in terms of cars compared to Turkey? And I mean, for good reason in this analysis, I've only done the relative changes, right? But it might be interesting to actually move to the absolute changes and actually look, how many people or working hours are actually being done the most and where, so to speak. I've also not touched on ongoing structural changes like electrification. I don't think it matters much for these results, but it's definitely something that's missing. It's definitely something that must be in some form integrated. And that corresponds to investment and profit data on the specific firms. Yeah. And again, like firm level processes of automation and how decisions are made, and equally industrial policy. Like all of this is obviously missing here. And finally, the specifics about employment and automation technologies. Again, I'm just a list to show you that I'm aware of what is not here, but which I want to do in the previous sort of analysis. Yeah. Okay, I think we have about an hour now. It's 3 p.m. already. Tommaso, Sebastian, what do you think? Should we have a small discussion, or should I show you quickly what I have for the 3rd chapter of the dissertation?
Perhaps we can have a discussions. You can show us again the table with the national results. That one, I guess, that can be interesting, because my feeling is that as GERPISA researchers, we specialize in regions and country, which makes sense for ourselves.
Yeah.
While what you do is something that we're not used to deal with, which is what is going on as a sector globally. And one question is, it can be, does it make sense to get that level of aggregation? And so that's why I suggest to my suggestion to you was to go back to national data to see what gets out of that in terms of and it seems that it contributes already to explain some of the things that you were raising as paradoxes. So perhaps we can have a discussion about that, and then when you reply, you can if you want start up to get into more the qualitative part of your work and see how it complements, because I think that it raises. First of all, I really appreciate the fact that, as you say, most of the people who do this work do not share all the bad data, not meaningful results. They do not question their, they come and they say, look, I found positive correlation between these and these, and that's it. And sometimes we are those who raise those questions and start to say, but look, perhaps, as far as we know, even if you select the data that makes most of the sense, it doesn't really make a lot of sense for us. So I think that is the first interesting point, is to open up to a little bit also the black box of how you get results out of these work. Sometimes you just engineering some results by selecting what makes sense, and you discard the rest. But I think that is more interesting to try to make sense of what doesn't make sense, as you are trying to do. So that's my first remark. So that's I've already made some comments to you, but typically, when we're thinking about country dynamics, and then I get into more kind of quantitative, but also qualitative approach by respect to the kind of aggregation you do, is that, for example, if you have factories that are growing or not declining, we do know that these contribute to value added, because it creates economies of scales, because it allows to keep a younger workforce, because it keeps attracting investment. So, for example, in the case of France, or Italy, these are two fast declining countries in your period. So that means the production keeps getting lower. That means the economy of scale goes down. So value added might be affected. That means also that the workforce is not renewed. So also that affects productivity. If you have a 20, that's for example, I shift now, but for example, in Japan, I remember that there was this debate in the 1980s about labor productivity in Japan. And there were all these data about final assembly factory in Japan showing a huge competitive advantage of Toyota and Nissan factories by comparison with American and European one. And that actually became the base for the lean production paradigm, saying, look, they are so much competitive, there's no way you can survive. So you need to use the same method they use. And so that was the lean production interpretation. But already at the time, there were other peoples that were doing this, approaching that a little bit differently. And then, for example, Cusumano said, yes, but come on, when you look at the vertical integration, that was in the 1985 books, but you realize that an assembly factory of Toyota is actually much less integrated. It does much less things than a Ford factory or GM factory. So you don't have to compare the two, because otherwise, of course, you have a bias in terms of labor productivity, because they do not assemble the same level of value. So the Japanese Keiretsu already provided kind of modules or sub-assembly that were integrated in the cars, but actually European and American factory in the late 70s and 80s were actually more vertically integrated. They were still doing a lot of assembly of components inside the factory. So when you take that into account, Cusumano showed that the productivity advantage of the Japanese factory was much less. And then some other guys, I don't remember whom, but you can find that and I can pass to you, did what you do. So it said, let's take the labor productivity of the whole sector. And then he found out that actually, if you took the old Japan in the 1980s, its results were debatable, but you had less labor productivity than the United States. because you would integrate all the small keiretsu plants, and there were many, with like less than 5 employees, and then the labor productivity would go down dramatically. And also, other colleagues of us found out that the average age of a Toyota factory was much younger than the average age of a Renault factory, also because of the way the keiretsu was organized. So all these factors might play a role in your story. Okay, so declining, growing. So for example, we talk about utilization ratio of capacity. The higher, well, you would expect the higher productivity. So to check these, I think that how do you check about these factors? By reducing the degree of aggregation and go into more and more smaller sample in order to check about some hypotheses. And so this is the first step to me. But then, as I told you, I guess here you aggregate very different companies, suppliers, car makers, and sometimes you aggregate different industries, you know, premium, mass. So the value added of BMW per car and per employee perhaps is not really the same as the value added of Volkswagen, which is not the same as the value added of Fiat. Now, of course, you're measuring a ratio. So you say, well, the ratio should not change, because I want to know if it's increasing or decreasing. But then you get in these real trajectories, which can be very different. So I think that you are on the right path in terms of asking questions, and in the 2 directions, which is question about the method. So how do you make these quantitative econometric analysis of aggregate data meaningful? And the right methodology, in my opinion, is to go towards more grounded understanding of what is behind these results that do not make sense. So I think that you're doing right. And perhaps other people in the room might tell you, by looking at specific country that they know very well, they can tell, as I just did for you, for Italy and France. So say, okay, Italy and France. So France, if I got it right, France, you have very slow productivity increase, a decrease of output that is less than the decrease of employment, which explains for the increase in the productivity. And you have what is robots minus 4.6 in your table?
That's the absolute number of robots.
Okay, but the robot density is increasing.
Exactly. That's why I said France is a strange, interesting example.
So France is really declining industry. Okay, so you're a minus in your period. What is 2009 2019? Yeah. So 2009 2019, you are around minus 40% in terms of volume of output. But at the same time, what you have is that France is offshoring all the production in the lower segment. So low value added products, not in absolute terms, the relative terms, is going out. And what remains in the country is higher value added products. So you have a sort of compensation. You have a decline in volume, which is compensated by a sort of a market specialization of what is still produced in France. So that can explain some of your results, for example. Then, so that my opinion can be a good explanation there. Then you have a continuous reduction of employment. Now, employment. Do you account for agency workers in the employment that you have here or not?
Good question. It's that's one of the things where I think sort of like economists at this kind of research really go wrong, because no one tells you. So essentially, all the sources for the hours worked that I have say these are the millions of hours worked in this sector by their national definition. But no one says what the national definition is. I know in Austria it would be contained, like the temporary labor, but I cannot say for anyone else. unfortunately.
Okay, well, that could be checked at country level, but and then you have to check for each country. But it is, I mean, it is possible. I know that in France there is an increased use of agency worker, which means that this tends to increase productivity, I would say, because you can make a more intensive use of these hours of work, in the sense that you use agency workers when you need them at the peak of production. And then when you don't, you just get rid of them. Well, actually, when you have permanent workers, if you follow lean production principle, when the cycle goes down, then you don't exploit to the maximum all the hours of work you have. Even if in France, as Sebastian knows very well, there's been introduction of labor contract that allows to exploit better the time, in the sense that before the employer could not ask a worker to work 7 days a week for 2 weeks, then just work 2 days, then work 3, and keep changing that when you like it. And that's still true in some country, which you cannot do that. But in other countries, you can do that with no limits, which means that your hour of work, it's really a very highly saturated hour of work. That's typically of Central Eastern European country, for instance. So I'm just throwing to you a series of, elements that can play this. And my suggestion would be to try to make hypotheses, and then you can check with your data, which have a lot of limitation. But you can say, okay, I know that there are this difference between these two countries. Let me check what my data can tell me about this difference, or reduce the sample. For example, you have the Orbis database, which companies, and you can isolate assemblers from parts manufacturer, big companies from smaller companies, and check if smaller sample for one country or two, if you just reduce your sample to assemblers, large companies, does it tell the same story or is different? And if you bring in parts manufacturer, doesn't change the picture, and that can bring you more empirical elements to make sense of the story. And then of course you cannot do that for all the country, but you can focus on Japan, for example. That is quite intriguing, that one of the strongest country, well known for their productivity and improvement rate, that is still exporting a lot of cars, which is still dominating market share, is in your database a very poor performer. So that's a very interesting case. Of course, Germany is important. So the big producer, you can focus on them. You have a lot of data available. Then you move to, you take some strange national case, and then you try to get more data to answer the paradox. That would be my suggestions that can help to explain these paradoxes. And then is the relative weight of your groups. Then I think you start to go in the right direction. So the aggregate result doesn't make sense, because actually you have different stories going on. And then so when you aggregate, it's just the relative weight of one story or the other that give you the full picture. So that would be my final remarks. But I stop here. Perhaps other people have more methodological questions or suggestions, or so I open the floor to others, and of course we will keep having this conversation with you. Sebastian, perhaps you want to add something?
No, yes, I have a very, very quick question. Well, first of all, thank you very much for your presentation. Subjects that I follow very closely, and it was very interesting also because you try to, of course, tackle the mainstream discourse, the automation discourse, as Ben Hanaf says. But you also go beyond Ben Hanaf, because Ben Hanaf has a very extremely aggregated level of approach with productivity by country. So he has this hypothesis of the secular stagnation that comes from Brenner, et cetera, et cetera. And you try to show more concretely what does it mean by country, by sector. And of course, the automotive sector, as usual, is a very good example to show how it is concretely. So you yourself, you know that the density of robots as an indicator is very limited, because the ways you said it yourself, it's limited as an indicator, and it's something that Grzyński also says in his papers. But since you mentioned him, my question would be, do you make a distinction between automation and digitalization, and do you include the question of digitalization in this problematic of stagnation of productivity, and in the automotive sector in particular? I don't know if you see what I mean, but voilà, this is my question.
Perfect, thank you. Should I reply to the both of you, or should we wait?
Yes, you can reply, and then we will take other questions.
Okay. Yeah, I mean, everything you said, Mazo, is I'm obviously on board with. And thanks for the suggestions again. Like you've already made parts of them to me before. I also think it's the only way forward. I think what I'm sort of struggling, or what I'm thinking about, is how can I, because I feel like if I put in these considerations of breaking it down even more and going into more specific cases, then the paper, it's already so big, it's already so many variables. So my idea would be, how can I finish this analysis as a clean cut, and then go into the specifics. But I think this may be difficult, and I think, as you say, that the only way might actually be to look at the strange cases of these final tables, and say something additional empiric about them. Yeah, I think you might be right in this, but just to share that I really want to get this paper done with, like concluded, and then do the next chapter, which I think, or which I want to rely very heavily on these specific questions, right? Like, how have the specific firms, what have they been doing, and how have they developed, and so on and so forth. But I took a lot of notes again, so thanks again for all of this. And Sebastian, again, also like a good question. Thank you for the feedback. Yeah, I mean, actually, originally it was my idea, and I'm also a bit in contact with Aaron Benanaf. Was an idea to go a bit beyond him, in a way, or to be more specific, because I felt like, I mean, I find the book and the sort of the overcapacity and stagnation thesis, I find it convincing. But it makes, as you say, it makes the same mistakes as usually economists, which is saying, manufacturing, this is what's happening in manufacturing. What does it mean, right? So even though I fail still, I wanted at least to show that there's heterogeneity within manufacturing, which usually can be shown quite nicely with the automotive sector. Yeah, in terms of technological change in the automotive industry more generally, yeah, this is obviously a very difficult thing. And as you know, in Germany, I don't know how it is in France, but in Germany, digitalization is the big name of the game, right? They don't frame the research in terms of automation. They don't. I feel like that's a very country-specific thing, because in the UK and the US, it's very much automation-driven, in my opinion. And how does it relate? It's also, I mean, both terms are so difficult to grasp, right? Like, obviously, there's so much written on digitalization as well, but how to measure it, how to specifically engage it. I mean, I once wrote a paper with colleagues where we sort of did a similar variables for the entire German economy, and there we had like a digitalization index, right? And a colleague of mine, she like dug this out from somewhere, and I just found it so strange. I found it so unconvincing. It's just like, it says, how many times do your employees use a computer in their work day? That's a part of digital. I mean, I get where it comes from, but I don't think it. So yeah. So just to say, it is very difficult, and yeah, it's, I mean, I guess it's in the nature of things that we cannot say, be precise about these technologies and about these developments. But just to say, when I was doing a factory visit in the Austrian automotive industry, one of the lead engineers there was talking about the next technological steps, because I was asking him. And he was essentially saying, the biggest thing will be to digitize what is called the tool diaries. So the lists which say which tool has been used where and what. That is like a bunch of, it's still like a folder that they have lying around in this workshop part of the factory. And this will be the biggest technological step. So yeah, so it is automation, it's digitalization. Will it have employment effects? Maybe, probably, but it's like, yeah, just to say it's very, very difficult. Yeah, exactly. Did I miss anything? But of course, in the dissertation, I tried to sort of like differentiate and make a case, and what are we actually talking about? What is digitalization? What is automation? But I think ultimately you can only lose, right? Like if you define it in one way, reality will disprove it in some way, and so it's like, I don't know. Yeah, and robots are obviously like an insane measure to think to approach automation. I think I was talking to a KUKA engineer, and he was like, he really doesn't understand why people get upset about robots and the narrative about robots, because really, in his opinion, what killed the most industrial jobs in the last decade was injection molding. Which is just a machine. It's not a complex robot, intelligent automation. It was the most simple of machines. But yeah. But thanks for your points. All really good points.
There will be other questions, I'm sure. I was looking to your data and I'm struggling to understand. So please help me, and I think you can also help the others. For example, so robots, it is in this table that we're looking at, is the net growth in percentage of the number of robots in the automotive sector of this country. Is that right?
Yeah, so in this table are average yearly growth rates. So on average, and the robot category is the total number of robots, essentially. So if we say the US, between 2010 and 2019, on average, every year, the amount of robots has been increasing by 11.4%.
Okay.
Yeah, and the same for employment, and the same for output is value added, and productivity. And obviously, like productivity, output, and employment, they're the same thing, because productivity is output by employment.
Mm-hmm.
So that's why in France we see a productivity increase, but only
because the employment has decreased more than the output.
Exactly as you said, like through the bank, it just like everything got worse. But since employment got much worse than output, it's still a productivity plus. Yeah.
And the robot density is the number of robots per is how much the robot density has increased. Is that right?
Exactly. So that would be, so the increase of the robot density would be an increase of the number of robots compared to the workers. So that could either be fewer people working there, or same amount of people working there and more robots, essentially.
But what your measure here is the increased ratio between 2000 and 2019. Is that right?
The yearly growth rate, yeah.
The yearly growth rate. So
yeah. So I calculated how they actually grow, like from 2010 to 11 to 12 to 13 year by year, and then I took the average.
So that means that, for example, in Japan, the number of robots has decreased by 3% each year.
Yeah, on average.
On average.
And that's what I said. It's difficult because it could have been increasing very small every year, and only one year they lose like a lot, and then it would still show up as average 3%.
So you know that in your data there is this. So you could put some additional like standard deviation or something like that to check about that.
That's true. I could do it. I mean, for example, I tried to show it with this one growth rate, the 5-year centered moving averages. Here you see how volatile it really all is, right? So if we look at Mexico, the Mexican automotive industry, from 2014 to 2015, it decreased by 18% productivity. And then the next year, 22, but in between, it was like growing by 4%. Yeah. for example. But you're right. This I could actually reproduce for the interesting cases, perhaps.
How much these single years determine much of your results. And yeah, I would also introduce the something that which countries have a relatively stability in the level of output, and in which countries there is a big variations, because something to try to highlight where the anomaly comes from. Because if I go back to your previous table, it looks really counterintuitive. That's like, I don't know, Germany has a decreasing ratio. I mean, as an increasing ratio of robot density increase, but less than France. And that is counterintuitive about the presence of robots in the two industry. And so it could require some explanation that might give you some ideas of why this is showing up.
I mean,
Portugal has a dramatic increase in robot density, for example. Like Austria, there are two small countries. I don't know, they're really challenging results. And so in Romania, you have like 67% increase in robots, but the robot density increased very little because there is a huge increase in employment. Is that the reason why?
Exactly, that's how I would interpret it.
I guess that is they're very interesting result, that they're so different. You would expect these countries to cluster in a much stronger way with group of countries that have similar path and similar development. But it doesn't seem to be the case. Even Romania and Slovakia, which are on similar trajectory morale, you see that the level of output and to a certain degree the level of employment, but Slovakia has increased productivity, but much more. But yet the robots have increased much more in Romania. So, and that's you have Skoda and Dacia. Okay, it's value added much higher for Skoda products. But just these two countries, these are challenging results to make sense of it. And
completely.
Yeah, so that would be.
You need to go visit factories in Romania now.
Apparently, Pisa.
For example, I was noticed that labor productivity in Canada, Mexico, and United States. I mean, you have this amazing, very negative productivity of Mexico, but these are in the same region. So they are strange, but at least they are all in the same market, and this seems to go together to a certain degree. Then it would be more interesting to understand the difference between Central Eastern European countries. That is your topic. You can concentrate on them and understand by looking at other variables what makes the difference between these countries, because they are similar, not exactly similar products, but you can differentiate them. So I guess by grouping countries by value chain, regional value chain, so Europe and Eastern Europe in particular, core countries, the North America area, US, Mexico, and Canada. Perhaps that could be another way of reorganizing things that would make more sense.
That's a great idea. That's a good idea. I'll definitely try this. But yeah, as you say, it's very confusing. I think that's also why I haven't found the definitive results yet, because they don't show themselves. But I think, yeah, by clustering it by region makes a lot of sense to me.
Normally you talk about core European countries, Germany, Italy, and France. You can add UK, but it's not anymore really, but still. Then you have the semi-peripheral is more like Spain, but Spain is the big one. Then of course you have the small one, Netherlands, or there's no Belgium, and then you have the Central Eastern European country, which you can cluster them together in this group. Mexico, Japan is a kind of a country on its own with perhaps a specific statistical. You can treat that separately to a certain extent, and I guess by clustering that to see if to explain the differences within countries with similar trajectories would already make some perhaps more sense. That would be my suggestion.
Perfect,
okay,
yeah.
I've been talking a lot. So are other questions, suggestions?
Hello. If I may quickly jump in, Michal Hrubý from Czechia, and I wanted to ask, actually, when you present this data and these variables, have you also tried to include some more variables on the national level, which maybe could be available when it comes to the employment statistics? Because I mean, in some other papers, and I know you said that you don't like really the economic approach to these granular, less granular data. But have you also looked at, for example, the average age of workers and all these statistics? Because in some literature, robots are usually connected to the structure of employment. So maybe in some countries, the driver for higher robot densities can also be connected to this age structure, and maybe some constraints on the actually labor supply availability. So maybe such statistics, have you also tried to look at it from this angle?
Yeah, that's a very, very good point and a very good question. And yeah, I think Acemoglu and Restrepo in one of their 20 papers on robot use, I think they make the demographic argument as well. I haven't done it because given that the panel is so many countries, I just didn't want to overdo it. But it would be the idea to in the next stage to somehow, if I focus it on the Central Eastern European region, to then actually consider occupational data, demographic data, and see how they precisely interrelate. So yeah, thank you. I appreciate it. I haven't done it, unfortunately, because it was already so much work to get these variables, into the thing that I yeah, it just felt like too big. But it's definitely, yeah. I also know of a colleague at an Austrian university who did precisely this for the Austrian case. And I think his results were, no, I don't remember now, I can't lie. But yeah, it's definitely relevant, very relevant. Although it seems very interesting from the qualitative interviews so far that I've had, that automation is not really treated as a viable option for labor shortages, right? I mean, it's a really big thing in Austria. I don't know how it is in the Czech Republic, Germany as well. So everywhere I went, people were very heavily complaining about labor shortages over the last couple of years. But the tenor was very clearly that if they could solve it with automation, they would, but they cannot. And I'm still not sure why exactly, but I hope to find it in my interview data somehow. But yeah.
But I would say that maybe that also goes in the direction that what labor is actually on shortage, because I guess at least now what I see, like in Mladá Boleslav in Škoda Auto, is that yes, of course, I mean there is always a lack of labor force in a sense, but this is usually for those occupations which really cannot be automized in the sense of robots. And plus there could be also some effect in the whole concern, because usually I guess that the robots which are actually, for example, applied in Czechia in Škoda Auto can also be, so to say, like a spillover effect of the technologies which are driven by Volkswagen and stuff. So there can be also such effects.
Yeah, completely. I mean, also in the interview sample that I had, it also varied quite a bit. but mostly people in Austria, at least, they're looking for everyone they can at this point. So they're looking for low-skilled, whatever that means, high-skilled, like throughout the bank. They just don't have anyone, like enough people. And then there's the specific logistics automation company, which is fairly famous. It's Knapp. They're mostly looking for mid-skilled people. So they're neither interested in low-skilled nor very high-skilled. They just want people without a university degree, which can install these automation solutions. So it's a good question of what actually these labor shortages mean and address. But in the automotive industry, I think in Austria, it's quite clear that they mean everyone. Yeah.
Yeah, but thank you for the presentation. It was really, really nice to listen to that.
Thank you for your comment.
Any other questions?
Yeah, is there anyone else who wants to ask questions?
You know, Benjamin, when you say it about why they cannot automate that, is that the automotive, this is something that we have written together in a working paper with Martin and Boy Luce for the ILO organization. I will pass on that. And we just relied on previous work by Taka Fujimoto, Ulrich Jürgens, and Shimokawa that basically say that everything that could be automated efficiently in the auto sector was done basically by the 80s, early 90s. An attempt to automate it was what is still not automated, which is final assembly, at least for the car makers. Basically, the attempts made in the 80s failed. And then the lean production paradigm is more about teamwork and labor flexibility. And that's why people say that Toyota, for example, is extremely conservative about automation. And it usually does really for ergonomic reason, but not with the perspective of substituting the worker, but just to make the work more efficient or less demanding in final assembly. So whenever you have a variety in products variation, you have to assemble many parts and it's moving fast. There is, at least with the lean production paradigm, a strong emphasis on keeping human workers on the line, teams. And there is a debate now about whether or not electrification, because it simplifies the products, powertrains, that's clear, but also components and parts, and the product architecture in general can be drastically simplified. Could not be an opportunity to automate what was not automated before. And then I guess it really depends on what kind of electric cars countries and companies are manufacturing. So we are in that question. So with Sebastian, we'll start to look into that. And I know that Sebastian was in Electricity, which is the new plant that has been established by Renault recently to manufacture exclusively electric cars, and has not seen this. I mean, if neither more digitalization nor more automation, but more lean. I mean, still lean and optimize for assembling electric cars, but not a change of paradigm. And I guess in the German automotive industry, since you have very high value added cars with a lot of components, you will have the same. So that kind of product are not very different. So there is this idea that electrification might open up a new opportunity for automating things, but we haven't seen it yet. And when you look at the products, they don't seem products that are really that simpler by comparison with what they're substitute. They could, in theory, that's why there is the opportunity, but they are not, in fact.
Yeah.
But that would be the answer as why companies are, there is just not, nobody's really proposing technological solution to fully automate nowadays the final assembly, as far as I know. So companies do not have a choice, and there is no prospect. I guess that would be my answer to your questions.
Yeah, those are really, really good and interesting points. Actually, I was thinking doing a bit of a project. Maybe we can do this together, because in Upper Austria, BMW is about to change its. They produce engines, right? They're one of the 3 big BMW engine plants. And in October 2024, they're switching to the electronic engines, essentially, the production. Electric, yeah. And the idea would be, or my idea was to sort of like accompany this process, because I have good relations with the work council, work council head there. And he said he would sort of like, allow or make possible the access. Because one of the things he said, for example, was that they considered it as a win that they would take over about half of the people now working in combustion engines to be working at the new electronic engines site. So they, from the product alone, they have like the half of their employees, because as you said, Tommaso, the process is more simple. I don't know about the precise steps in work organization and production, but I think it would be very interesting to follow this. I think it would be very interesting, because then you also have the workers from the combustion engine side who have been retrained and start at the new side. So that would be a very nice. So if you guys are doing something like this as well, then maybe I can make a case study, country case study for you. Yeah.
Absolutely.
Can I say something? No, just continuing what Tommaso said, if no one else wants to talk. That, I'm really looking forward also to hearing more the qualitative part of your research. And as Tommaso said, we were with some colleagues in Renault Electricity, which are the 3 Renault factories in the north of France, trying to take a look at digitalization, because here they use the term digitalization, and also electrification. And as Tommaso said, there is no like radical change, just very pragmatic implementations of new technologies. And with Tommaso, we're also trying to formulate this. We're trying to finish a paper where we try to approach this issue through the idea that today digitalization is inside the automotive sector, at least in France, particularly in France, has no like radical effects on work productivity, things like that, because it's a very top-down process, and it appears, as we say, like a solution in search of a problem. So they have these solutions, and they cannot find still like very concrete applications, like a company-wide distribution, a company-wide implementation. So they have only these like a very context-specific implementations. So this is how we have been approaching this question of digitalization more specifically.
Interesting, yeah. Very interesting, very interesting. Also, that France, the discourse is also around digitalization. I thought it was a Germany, Austria-driven kind of thing. Very interesting.
Can I quickly jump in? I have a bit more technical question. When you showed the econometrics at the very beginning, like actually, not sure which slides it were. Yeah. Just you work with lagged variables. No, I mean in the yes, yeah, here. Yeah, you work with lagged variables. So I just wanted to ask about this, like what was the reason, and just maybe describe it a little bit more, because I see that some are lagged and some are not. So
I think all of them should be lagged, at least the explanatory ones. And the reason was simply to take one step against endogeneity, mostly, because obviously that's in this setup that's a question, but in like all econometric setups, I think in some form or other that multicollinearity and endogeneity are a question. And I talked with a friend of mine who's much better in econometrics than me, and she essentially said, yeah, just lag them for a period. So I was like, yeah, okay, why not? But you're right, I did not mention this in the interpretation, and it makes it a bit more complicated. Generally, this is a very difficult, it's not very difficult, but it's a difficult table to interpret, because it's lagged logs of relative of variables, right? But okay, so that was the logic. I think capital intensity, at the very bottom, it should also be lagged. No, actually, capital intensity we did not lag because by the rationale that it would not be period dependent, right? Because if you're a mining, I mean that's a bad example now, but yeah, if you're a mining company, factory, whatever, your huge machines are not going to be so volatile to period changes, right? You will buy them for 10, 20 years probably. So I think that's why we decided not to lag capital intensity, or it's lagged and I just didn't put it in the table. One of these two things. I'll have to check again. It's so much data work. No, thank you. Yeah. Exactly. But yeah, I did the electrification thing again to connect to this what you said, Sebastian. I think it's very, very interesting, and I think it's very relevant. And also maybe in terms of the organizational structure, it will likely maybe be the same. But I found it so striking alone that the worker council considered it such a positive result that they could save half of the employees with electrification, right? And that's I mean, it's a huge plant. That's a BMW in Upper Austria. I think they do 5 million combustion engines a year right now. So I don't know how much they're going to be producing of the electric engines, but at least for sure it will be very interesting to see. Because in Germany they're already doing it. I think in Ingolstadt they're already running this new Mark IV electric engine. But yeah.
The plant will keep producing internal combustion engine, or it will completely stop and produce only electric powertrain?
They will overlap until as long as they can, they said. I mean, that's the worker council. I haven't spoken to management on this because they didn't give me access. So in the beginning, they will start the production, and then they will continue combustion and slowly, sort of like as the law
when they say they will keep half of the work first, is by the end of the transitions or at earlier stage?
At the end of the transition, like all things done, all things changed. So at the end of the combustion engine, there will be half of the people working at the electronic engine plant than right now. Yeah,
that's the kind of commitment of the management about an agreement they had about this transition. That's
exactly. Okay. Exactly. Apparently that was an achievement for them in some kind of negotiations or whatever they did.
Because I recently heard about that. I cannot talk about that. In France they expect the transition to, but that is sector wide, not just the powertrain, but the powertrain should be more it than anything else.
Yeah.
But the sector wide is like 70% less.
Wow. Yeah. I can imagine that because
I cannot tell you, but I was very much surprised that it's like 70%.
I totally believe this because this is also I mean, when I was talking to this work council head at BMW, they have a history of, I mean, they always lose against management, but they have a history of actually winning some battles also with their European colleagues. And they managed for their logistics part not to get outsourced to a company close by, which would have, and they would have like rationalized half of the people away and intensified work for all others essentially. So maybe that's why he described it as a win to retain the 50% because they're not losing 70, right? So they somehow managed to make a social partnership agreement of like at least keeping half of the people.
Yeah, I think for a powertrain plant, I think is a good deal.
Yeah, completely. Yeah. Sure, yeah. I mean, in Austria more generally, since it's so supplier heavy, this is obviously also a very big topic. Because I was talking to the head of the worker council at a sinter plant. Like they make these parts for the combustion engine, these very hard parts. In German, they're called sinter parts. And she said essentially she has to believe that, and that's the worker council. she has to believe that this law, this European law on the ban on combustion engines will not come to pass, because if it does, essentially the entire factory will be gone, like, because they only produce combustion parts. And they've started the sort of like development of producing parts of electronic engines, but it's not that easy apparently, and it will be a very, very deep cut. But it's also still quite far away, I feel like. So far, the period is denial, I think, for most people. Like, no, they'll never actually abolish combustion engines. We'll have jobs in 20 years and so on and so forth. Yeah.
Again, any other questions? I was just wondering, in your presentation, you never really try to correlate productivity gains and country performance, which is also why it's counterintuitive. Because, for example, Mexico is one of the countries that has gained most of the production in this period, in particular after the 2009 crisis. Mexico has acquired a huge share of the North American, has been really the winner. And in your data, it seems that it has achieved that. And that, of course, explains why employment has increased.
Yeah.
Now, what is interesting is that output has increased very little, but production volume has increased very substantially. So that might be also a matter of multinational company extracting value from the country so that the country increase. So perhaps you could also check for some of your country labor productivity in terms of unit of production, and you can also obtain that for parts. It gets much more complicated, but how much production units have been achieved, and see if there is important variation with value.
Ah, very nice. Yeah, I was thinking about this. Yeah, where can you get data on production units, like actual, like not the value added, but what they actually?
Well, the production units is very easy. You go to OICA, and you know how many cars. You know, the cars is just a proxy for you, but you know how many cars a country has manufactured. You go just to the OICA database, and then online, and then you get all the data for all your countries, and you get since you take the automotive industry, I guess it integrates light vehicles, so commercial vehicles, and you get them as well. You get
that's a very good idea.
And of course, that doesn't give you a clear idea of parts, but they are often correlate. They're often correlate. So.
Yeah.
So Mexico has been really a winner in terms of production volume in the period you're looking at, and here looks like is doing that with negative labor productivity.
Yeah.
Which is counterintuitive, and then and France, that is being France has low labor productivity. That's Italy has a relatively high labor productivity gain in the period, is as high as Slovakia, if I see, and yet has been one of the big loser of that period. So you see, you can check for these because normally you expect labor productivity gains to produce also growth in production, to increase the competitiveness of a country. This is part of the discourse that you need to reduce costs, and so to increase labor productivity, because you are in competition for the location of products. So when you do, normally it is a sign that you are competitive, and you normally should increase your production, either because the country becomes more competitive, or because you gain more competitive as a producer, or for themselves, or for multinational companies. And perhaps including units, because that could also bring into you the fact that output in countries like France and Germany can be also the result of their capacity of concentrated value produced elsewhere, while in Central Eastern European country and Mexico, you have a problem of value capture. Normally, this is better addressed not by output, by value added. So I don't know if you can integrate some value added dimensions into your analysis. But I'm really very much surprised by for example, the Mexico value add, the Mexico output being so small. Because if I take Canada and Mexico, Canada has been very suffering a lot during that period. Mexico has been capturing a lot of production during that period, and US has been losing. Now, of course, if you start with 2009, which is really a bad year, that's also a problem. In the sense that your begin year and your end year should be similar. So for example, I don't know, 2019 works. They're similar years in terms of volume of production in many places. Not of course for China, that would be a completely different story, but in Europe and United States, you will find something similar. So also check if you're not comparing years that are so different. I know that it's the annual variations, but so that perhaps my remark doesn't make a lot of sense here. But anyway, check also for that, because United States clearly in 2009, they're down dramatically because they close a lot of factories. And then it goes back in 2010, 11, you have incredibly growth. So you have this swing down and up that you don't have in Europe, for example. I don't know, just some suggestion, but anyway, looking also for other indicators for labor productivity than just output, but perhaps value added perhaps is the same story, but volume could be another a way of measuring the capacity of a country because sometimes for factories they say how many vehicles you manufacture. That was a for when factories are compared, often things like these words. There is a private company that does that. It sells their service to all the car makers and provide the sort of labor productivity, and they look for hours per vehicle. Okay, so vehicle is like kind of things that matter. So how many hours of work to manufacture a vehicle, and that's often used. So you can introduce that to check if your output is not misleading here.
That's a very good point.
And you can find easily. I mean, but the country, cars, that's no problem. You can find. Okay, we're approaching the end of 2 hours. We've been talking mostly between us, perhaps to difficult data to deal with. Anybody else wants to have a last questions before we leave?
So there are no regrets.
With me, or what do you mean?
No, with the audience.
With the audience, yes, of course.
Maybe very last quick question, but I have never worked with this robot statistics. Actually, how granular data they actually provide when it comes to like what they consider robot, for example, and so on. Like, they have also some differentiations.
Not really, which is one of the big critiques of Martin Krzyzinski, that they essentially everything. I mean, the robot definition is clear, but it's 4 axes and above, because robots are usually, constructed with the axis as logic. So everything, but it's also a very problematic data set because it's not an official administrative thing, but it's essentially the big robot suppliers telling this IFR how many robots they have shipped to a certain country or region. Not region, just country and sector. And then they just take it for granted. And then they make their own estimations of depreciation, which are completely untrue, by the way, according to my interviews, of how long the robots will last. And then they make the stock out of it. So really, this is like a very imagined database, and they do have it for sectors. In that they are very clearly split, but there's no firm level, there's no regional level, there's nothing. I know that other sources like the European Manufacturing Survey, they actually do have some information on firm level things, anonymized, but they still have like a distribution, how many robots are used by which firm, something like this. but they're very constrained in the countries and very constrained in the time frame. So once again, it's a problem of no data, no good data, no reasonable data, really.
Yeah. Thank you. Yeah, thank you. Thank you.
I think that your problems can be solved, but it really require a lot of work, in the sense that, you know, you can increasingly check your data, for example. So investments in fixed capital as another proxy, and then you check if there is capacity increase. That's difficult to check, but if production does increase and you see fixed capital increasing, that is another way of measuring for investment in I would say something that could be approximate to technology, and then you can see if your robots statistics correlate or completely not correlate at all in some cases. So I guess that all these problems would require extra check by multiplying data sources. So that is, given the amount of countries you have, is difficult. But once again, I would suggest to concentrate in few countries that are the most problematic and start with them and see what it works. Also this, to add fixed capital investment as another proxy for technology, and then to check these with whether this fixed capital investment is just creation of new factory. It's not about upgrading the factory, investing in new robots or whatever. It just, you produce more. Or if that's not the case, then you can say that this could be investment that aimed at increasing labor productivity by other means than just labor organization. So that could be, you know, you could add elements and see if they, by adding on, it makes more sense, or you see some other things that make more sense and solve your contradictions. But I understand that at a certain point of time that there is a problem of value added. So how much time I'm going to spend more on this database, and what value do I get out of it? So I hope it was a little bit helpful for you.
100%.
Depressing.
Yeah, 100%, 100%. I think I'll have to find, a way to sort of do additional analysis to find something very clear and interesting, but also keep the time constraint, because I need to finish the PhD. So that's a tightrope I will have to walk.
Yeah, I would try. If I were you, I would try to check with some country if I increase, put more data or make a sample of companies, if that helps to make sense of that specific country.
Yeah.
And then eventually generalize if you find that something really works.
Yeah, for sure. Yeah. But thank you. Yeah, it was really great. Thank you so much for the talk and the discussion and all the comments. I really appreciate it. Once again, very useful for me. Unfortunately, now we didn't talk about the dissertation in general, which was a big object of discussion at the Weizenbaum-Institut. But no, but Florian Butolo and then Martin Kaczynski had some helpful pointers about the overall questions. But yeah, maybe we'll get to do it at another conference or something. Or
anyway, you know, now that JERPIS exists, our call for paper will be out soon. It's for end of June in Bordeaux.
In Bordeaux.
Oh,
yeah.
So
it will be the last week of June in Bordeaux. If you go to the JERPIS site, you will see that the save the date. So
amazing. Yeah.
Please go forward, apply, and so we will keep the discussion going. Of course.
And let's keep in touch to discuss electrification too.
For sure. Yeah. Let me know if there's anything we can.
Absolutely.
Absolutely.
So
thank you so much, everyone. Have a great weekend.
Have a good day.
See you soon. Bye. Bye.
Thank you. Bye.